Circle theorem, specifically the inscribed angle theorem. What is it? This is one of the 8 theorems related to circles. Why? Astronomers use circles to find the circumference of the Earth. Interesting fact, a male hippopotamus is called a bull. Before we start discussing the examples, let's show you why this theorem is true. Now let's read what it says. Compare the inscribed angle to its intercepted arc. The inscribed angle is 90 degrees and the intercepted arc is 180 degrees, or the blue part of the circumference. And 90 degrees times 2 is 180 degrees. And if we do it the other way, 180 degrees divided by 2 gives us 90 degrees. And that is the inscribed angle theorem. And now let us show you visually why this is true. We're going to draw another radius from the center through the inscribed angle. And if we measure those two angles, we get 45 degrees for both angles. So 45 degrees plus 45 degrees is equal to 90 degrees. And right now we have two isosceles triangles. And the base angle for the isosceles triangle on the left-hand side is going to be 45 degrees. And that means the third angle in that triangle is going to be 90 degrees, because 45 degrees plus 45 degrees plus 90 degrees is 180 degrees. Now let's talk about the other isosceles triangle and the other base angle in that triangle, and that is, once again, 45 degrees, which means the third angle has to be 90 degrees, and that gives us 45 degrees plus 45 degrees plus 90 degrees, which is 180 degrees. And if we look in the middle, we add all of the 3 degrees, 180 degrees and 90 degrees and 90 degrees, we get 360 degrees, which is a full circle. So that is why the inscribed angle is half of the intercepted arc, or the intercepted arc is double the inscribed angle. Now let's take a look at it with a different inscribed angle. We have 75 degrees this time. 75 degrees times 2 is 150 degrees, or 150 degrees divided by 2 is 75 degrees. So this works. Now let's show you visually why this does. So we're going to go ahead and draw another radius from the center to the inscribed angle. And now we're going to measure those two angles, and we get 40 degrees for one and 35 degrees for the other. So 35 degrees plus 40 degrees is equal to 75 degrees. And now let's go ahead and write down the other base angle for the isosceles triangle on the bottom, and that is 35 degrees. And that means the third angle has to be 110 degrees, and 35 degrees plus 35 degrees plus 110 degrees gives us 180 degrees. And now let's add the other base angle for the other isosceles triangle, and that is 40 degrees. And that means the third angle has to be 100 degrees. And if we add 40 degrees plus 40 degrees plus 100 degrees, we get 180 degrees. And if we add all the three angles in the center, 100 degrees plus 150 degrees plus 110 degrees, we get 360 degrees, or a full circle. And that is why when we have an inscribed angle of 75 degrees, the intercepted arc is 150 degrees. Let's take a look at one more example. In this case, our inscribed angle is 65 degrees and our intercepted arc is 130 degrees. And this works because 65 degrees times 2 is 130 degrees, and 130 degrees divided by 2 is 65 degrees. Now let's show you visually why this works. We're going to draw a radius from the center to the inscribed angle. And now we're going to measure each angle, and we're going to get 30 degrees and 35 degrees, because 30 degrees plus 35 degrees is equal to 65 degrees. And now we're going to go ahead and put in the other base angle for the isosceles triangle on the top right, and that is 30 degrees, which means the third angle in that triangle is 120 degrees. And now we can add all those angles. 30 degrees plus 30 degrees plus 120 degrees is 180 degrees. And now we can add the other base angle in the other isosceles triangle, and that is 35 degrees, which means the third angle has to be 110 degrees. If we add those, 110 degrees plus 35 degrees plus 35 degrees, we get 180 degrees. And lastly, if we add all the central angles, 130 degrees plus 120 degrees plus 110 degrees, we get 360 degrees, or a full circle. And that is why the inscribed angle is half the intercepted arc. And now let's take a closer look at the examples that we'll be discussing in today's video. Now let's take a closer look at example 1. Let's read the steps. Step 1, write down the facts. Step 2, set up an equation. Step 3, follow order of operations. Now let's read the question. Find the size of each lettered angle. Now let's take a look at the image that they gave us. They gave us 3 measurements, 100 degrees, x, and y. Now let's write down some facts to help us find the missing variables or angles. And fact 1 is angle BDC is equal to arc BC. Now let's take a look at the image once again. The measure of the purple arc is equal to the measure of the purple angle. By definition, that a central angle and the arc that is intercepted are equivalent. And now let's take a look at fact number 2. And fact 2 is angle BAC is equal to half of angle BDC. If we take a look at the image, we now have 2 purple angles. The purple angle on the right is double the purple angle on the left. And remember, you might have more facts or fewer facts to find these missing angles, but as long as you write down the facts, it'll be easier to find the missing angles. And now let's take a look at fact number 1 once again, that angle BDC is equal to arc BC. We can substitute x for angle BDC, and since we know arc BC is 100 degrees, we can say x is equal to 100 degrees. By definition, that a central angle and the arc that is intercepted are equivalent. And now let's go back to fact 2, where we can substitute y for angle BAC, and now we have y is equal to 1/2 of 100 degrees because x is 100 degrees and so is angle BDC. And half of 100 degrees is 50 degrees, so y is equal to 50 degrees. We have our 2 answers, and we have finished example 1. Now let's move on to example 2. Now let's read the question. Find the size of each lettered angle. And now let's take a look at the image that they gave us. They gave us 3 measurements, 70 degrees, x, and y. Now let's write down some facts to help us find the missing variables or angles. And fact 1 is angle BDC is double of angle BAC. So the top purple angle is double the bottom purple angle, and that is because of the inscribed angle theorem. And now let's go to fact 2, where angle BDC is equal to arc BC. And if you take a look at the image, we can say that the measure of the purple arc is equivalent to the measure of the purple angle. And that is by definition that a central angle and the arc that is intercepted are equivalent. And remember, you might have more facts or fewer facts to find the missing angles, but as long as you write down the facts, it'll be easier to find the missing angles. Now let's go back to fact 1, where angle BDC is equal to double of angle BAC. Now we know angle BDC is equal to x, and we also know angle BAC is 70 degrees from the image. So now we have x is equal to 2 times 70 degrees, and the result of that is x is equal to 140 degrees. Now let's go back to fact 2, where angle BDC is equal to arc BC. We just found angle BDC as 140 degrees using fact 1, and now we can say arc BC is equal to 140 degrees by using the definition that a central angle and the arc that is intercepted are equivalent. And now we can say y is equal to 140 degrees, and those are our 2 answers for example 2. Now let's move on to example 3. Now let's read the question. Find the size of each lettered angle. Now let's take a look at the image that they gave us. They gave us 3 measurements, x, 280 degrees, and y. Now let's write down some facts to help us find the missing variables or angles. And fact 1 is angle CDB plus the reflex angle of CDB is equal to 360 degrees. So we can see the 2 purple angles form a full circle, and that is 360 degrees, and that is fact 1. And now let's take a look at fact number 2, and fact number 2 is angle CAB is equal to half of angle CDB. If we take a look at the image, there are now 2 purple angles. The purple angle on the left is double the purple angle on the right, and that is because of the inscribed angle theorem. And remember, you might have more facts or fewer facts to find the missing angles, but as long as you write down the facts, it'll be easier to find the missing angles. Now let's use fact 1, which is once again angle CDB plus the reflex angle of CDB is equal to 360 degrees. We don't know angle CDB yet, but we do know the reflex angle of CDB, and that is 280 degrees. So now we have angle CDB plus 280 degrees is equal to 360 degrees. So we can go ahead and solve for the missing angle, and we need to do an inverse operation. Since we have plus 280 degrees, we need to do minus 280 degrees. Those two numbers cancel, and now we need to do it to the right hand side, and now we have 360 degrees minus 280 degrees, and the result of that is 80 degrees. So now we know angle CDB is equal to 80 degrees. We also know angle CDB is equal to x, so now we can say x is equal to 80 degrees. Now let's take a look at the image one more time, where we have 80 degrees plus 280 degrees is equal to 360 degrees, or a full circle. So that means when we add the green angle and the orange angle, it makes a full circle. Now let's go back to fact number 2, where we have angle CAB is equal to half of angle CDB. We know angle CAB is y from the image, and we know angle CDB is 80 degrees from using fact number 1. So now we have y is equal to half of 80 degrees, and half of 80 degrees is 40 degrees, so y is equal to 40 degrees. We have our two answers for example 3. And now it is your turn, so go ahead and pause the video so you can take your time to answer the question, and I will show you the results in 3, 2, and 1. If you got it correct, well done. If not, there's always tomorrow.